Hi, everybody. We've been talking about covalent bonding, and we've been talking about naming these covalent compounds. So let's talk about the properties shared by covalent compounds. First off, if something is covalently bonded, we call those small pieces molecules. These are molecular compounds. Those diatomic hydrogen, oxygen, nitrogen, chlorine molecules, those are actually molecules. Nitrogen oxide, water, nitrogen dioxide, carbon dioxide, those are all molecules. And if it's a covalently bonded compound, that's what those small units are called. To differentiate from an ionically bonded compound, and when you have something that is ionically bonded, that small piece is called a formula unit. And it is a small differentiation in chemistry. But if you are going to be a correct chemist, it is molecules if they're covalently bonded and formula units if they are ionically bonded. Now, covalently bonded compounds are going to primarily involve nonmetals and other nonmetals interacting. Are there metals going to be involved periodically? Absolutely. But they're not going to be the majority of the atoms involved in a covalent bond. It's going to be a lot of non-metallic stuff. And think of the metals in there sort of as the spices. They're not the main dish. They're the spices that are going to be interspersed in those chemical compounds. Covalent compounds are all going to bond involving sharing electrons, and that is what is going to create those bonds. Covalent compounds at room temperature are going to be found as solids, liquids, and gases. And that's because the covalent bond can be both very, very strong, and it can provide a tremendous amount of flexibility. Flexibility to hold molecules together even when the compound changes state from a solid to a liquid to a gas when heat is applied to a material. Now, covalent compounds can make up about 95% of all the compounds that chemists have found on planet Earth. This is a lot of the important things involving living organisms. The important chemicals that make up you, me, plants, animals, food, fuels. This is a huge, massive area of chemistry. Everything from paint to all of the jams and jellies you use to make your life happy, as far as perfumes and hair products and shampoo and hand cream. All of those are going to be covalently bonded. So this makes up a tremendous amount of what you and I encounter every day. Now, these covalent compounds can range in strength. Some are the strongest naturally occurring substances. These are covalent compounds that can create what are referred to as covalent network solids. So these are covalent bonds that their structure, their shape, has produced the strongest things we know of. If you remember back to junior high earth science class that many of you may have taken, the hardest naturally occurring substances, diamonds, are actually held together by covalent bonds. This is carbon covalently bonded to other carbons, but it is the shape of that molecule that gives it that strength, and that shape is a strong tetrahedral, four-sided, covalently bonded shape. Mountains make up covalently bonded or are made of silicon dioxide. If you look at the elements that make up the surface of the Earth, the two most abundant elements are silicon and oxygen. These are not metallic elements, but the silicon and oxygen that make up this about 75% of the surface of the Earth, what form are they in? Well, most of them are in the form of silicon dioxide in a strong triangular sort of shape. And that makes things that are very, very strong. So covalent compounds can create strong structures. But on the other side, they can also create things that are really flexible and really squishy. This is the reason why humans can have squishy faces, because the skin, the muscles of the human body can be squishied around into lots of fabulous, wonderful shapes. foods, cheeses, things like that we can squish and move. Fabric, muscles, rubber, plastic, the fact that we can have Nerf and toys like Barbie dolls that can be molded and changed are all due to this flexibility of these fabulous covalent bonds. Some instances they can be very brittle. Glass, obsidian, which is a natural geologic form of glass, diamonds can be cleaved very, very cleanly and in a sense can be quite brittle. Again, another property sometimes of this covalent bond. And if you are coming up with an impression that, hey, these covalent bonds can be very changeable, you're right. There is that tremendous versatility that presents us with the vast array of things we see on the planet. Sometimes covalent compounds can be gases, the nitrogen, oxygen, and other things like carbon dioxide that make up a majority of our atmosphere, covalently bonded. Nitrous oxide, which can be used as an anesthesia, covalently bonded. Ammonia gas that you smell when you are cleaning with ammonia, covalently bonded. These bonds are incredibly important when you study the chemistry of life, and this is a beginning chemistry course. Many of you, especially if you are going to go on with your studies of chemistry, are going to either take a biochemistry course or an organic chemistry class, and some of you are going to take both. But biochemistry is that where biology meets chemistry. That's going to be the chemistry of life. The protein molecules, all the interactions of how chemistry relates to those biologic processes. Organic chemistry is the chemistry of the element carbon. And carbon, I've said in other videos, carbon is the big dog. Carbon is involved in over 90% of the chemicals that are out there and a very important molecule. And that's why we have whole courses designed around just the chemistry of that element.